Gummy bear sacrifice.
Jimmy's like, I want one. Nah, I'm not gonna ask.
Okay.
I'll give these.
Matches. One.
Baby bird, stop, baby bird.
Ooh.
Ooh, I have
Okay, we see if our gas is on.
Wait, I got Instagram this. His matches be on point.
It's an automatic play.
You know, they cost some money.
I need them 5 legs, Brent.
You know, them cheap match stuff. Like, what is this? What is this?
Okay. Yeah, like a red light should turn on?
Yeah, I guess you can make a key.
Oh. It just turned on.
Right there.
Yeah. Oh, no, the key should be in the little island up front, I think.
Island? We have island? Where the water is?
Ooh, like,
Oh, so we in Hawaii? But where the water is? That's a YouTube.
You guys read that backwards?
Uh-huh.
So this is our starting
Oh, wait,
product. Right? This is a decomposition reaction. So we are taking... Oh, I hear gas. We are taking potassium chlorate.
Oh, that gas is a lot.
like you.
This reminds me of soap.
Brent, you be scared.
So we're taking potassium chlorate, and we're going to decompose it into, what's that called?
Potassium chloride.
Potassium chloride and oxygen gas. Okay? So this first part here is going to be a decomposition reaction.
Oh, it's dangerous.
It's not very exciting at first. We won't get excited until we drop a gummy bear in there. So what we're trying to do is basically make this stuff molten.
Your hat is like.
Can you move the thing down like a little bit?
Thank you. Thank you.
Yeah.
Yes.
So all we're doing right now is taking that potassium chlorate, decomposing it into potassium chloride and oxygen gas. And it takes heat to do that. So you should start, if you look underneath, you can see it bubbling. That's the oxygen gas coming up. Do you see it?
Yeah.
Just a tad. Just a little bit. I see a little bit. Okay, let's try. The tube is on fire. So.
What is he doing?
I am real. But it's hidden.
Yep.
Do you want to thing?
Yep. Okay. So we're pretty much decomposed. Yeah?
Yeah.
Alright. So the next part, this is where another kind of reaction comes into play, called a combustion reaction. In a combustion reaction, you take a hydrocarbon and you react it in the presence of oxygen. And you'll always make carbon dioxide and water. So this hydrocarbon could be candle wax, could be gasoline, could be the... Yeah, that's the wax. Could be the gas coming out of here, the methane maybe, or the propane, right? Okay, so we're looking pretty hot there. So, from this decomposition reaction, we made a bunch of oxygen gas. Now we can combust this oxygen gas with this sugar to create...
Wait, that's sugar?
Gummy bear? Sugar.
Oh, I thought you were wait.
Are we ready?
Okay.
Well, I'm going to drop it in and then close it.
Oh, shit! Boy got scared. Yo, boy, PJ jumped back.
Oh my god.
That's perfect.
Poor gummy bear.
Is it still eatable? No.
This is still.
Is it still eatable?
Wasn't it flying?
That is nice. We should do that again.
Cool.
I ain't recording none of it. I already realized that. I paused. I didn't record none of it.
I recorded everything.
Yeah, we'll drop one more and see if there's any left. I doubt it though.
Do that over again.
Magically do it. We gotta set it all up again. So, can't do it right now. Yeah, so the products of that combustion, carbon dioxide and water. And we'll talk about that more in a second. So we took the decomposition reaction, and then we used some of those products as new reactants
Smells like s'mores.
for this reaction to kick this on further. Alright, cool. Go take a seat. Dance. Okay. Angela, you're dancing by yourself.
Oh, I know where this is going.
Dance.
Yeah, we're doing
Move it.
some.
I have to say.
You're replacing me. You're replacing me. Patrick, you're replacing me.
So let's not
Patrick,
wiggle,
are you gonna replace me?
I can't dance.
You're
This is what we're talking about right here. This is why I'm dancing. We're talking about what's called single replacement.
He's a jerk. He's gonna replace me.
Okay? In a single replacement reaction, you get something, they often show it like this. AB plus boron C goes to make AC plus B, right? So this is like, we could say PJ. This is Sol. And this is Angela. So in this reaction, typically what happens is... What?
Angela.
So in this reaction, typically what happens is like replaces like. Okay. So dance. Ready?
I can't dance.
Hello.
Just
Bachata.
I'm going to the shake.
Shake it. We can't really hear.
Just go like this.
Okay, dance. Move to your own beat.
Go back and forth. Like
Okay, so then in the kill direction,
Okay, go back and forth.
we have our girls going to replace the girls. So ready? The clap means we've reacted. Awesome. So now Sol is dancing by herself. Right? Here is Sol.
I don't need anybody.
Right? And then we have PJ. And we have Angela.
I'm starting to get dizzy.
Angelea.
Okay? Single replacement. Sometimes called single displacement. Same thing. Alright? Cool. Thank you guys. Round of applause. So Marco, if you're given something like NaNO3 plus Cl2, who's switching in that situation?
CL and NA.
Yeah, so we would get something like NaCl plus NO3. Right? So you have to be really good at identifying who's a cation, who's an anion, who's going to be switching it up. You have to keep in mind that these charges, right? That's +1, -1. So if you were making if you did this instead, MgNO3, would that be right? No. Right, you need a 2 there. So things like that, you have to keep in mind. That screws up my kids all the time in Aspen. I'm sure you guys run into the same thing. It's like you forget to balance for charge. If you forget to balance for charge first, and you go try to balance the whole equation, you're just in a whole world of hurt. Right?
This is where you're trying to find kind of places like this is where your periodic table can really help you, because you can say, oh, I know, chlorine kind of,
Right.
maybe reacts similarly, so maybe that's what's kind of going to happen.
Or like
That's
who's
gonna
metal,
replace
who's
it.
non-metal. Right? Questions on that? Okay.
Nope.
All right, now I need 2 boys, 2 girls.
Me.
All right, Juan and Marco.
Said me first.
Now you have to pick Diana.
Alejandra.
Diana.
Diana
Diana.
How about Maria and
Diana.
what about Shalom?
No, Diana.
Okay, let's do
Diana.
Alejandra and Maria.
Mama, you can have these making them
Okay.
Ow!
Bye, chicos.
Oh, it's that.
Come on, why not? Why not?
In the chemical world, that wouldn't work because you would repel, right? Your charges. So, dance.
I don't want to play this game. Just follow me.
You like smaller dance.
Let's do the sway
You
back.
have to hold the hands and dance. There we go. Like middle school dance, right? Where you're like,
Yeah.
okay. So what we're talking about now is not single, but double. Right?
Da 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 da.
It's very similar. Same thing kind of happens.
Da
Where you
da da da
A, B,
da
C,
da
D, goes to
da
A,
da
D,
da da
C, C.
da.
So same thing, like things will switch partners. So girls, why don't you grab a new boy? There we go. And we just made 2 new products. Chemical reaction. Yep. Did I get it wrong? Oh yeah, you're right. Awesome. Very good. Thank you guys. A round of applause. Okay?
Can you get off this table now?
So typically where you're seeing this kind of double replacement is often with polyatomic ionic compounds. So you might get something like NaCl plus, I don't know, FeOH3. Okay? So who's doing what? Who's dancing now? NaOH3.
NaOH. And FeCl.
Yeah.
Yes, yes.
Now is that right? Are we all happy? What do we think?
Yes.
So so that's kind of the bare bones. So let's go back and look at charges here. Sodium, what's its charge?
1.
2.
Plus 1. Look at your periodic table.
Okay.
Chlorine,
That's -7.
minus 1. So that's cool.
That's
If iron, do we know its charge?
No.
We can figure it out though, right?
3.
What do we know what OH is?
-1.
Yeah, negative. That's always minus 1. There's a 3 here. That must be plus 3, right?
Yeah.
So knowing that, those charges are same on the other side.
CO3.
So we get plus 1, minus 1. We happy? Yeah. Plus 3, minus 1. We happy?
No.
What do we do?
CO3.
We bring this 3 here to balance for charge. So now that's our skeleton equation, right? So that's a double replacement. Everyone swaps partners. Okay. Are we balanced?
No.
No.
Can we balance it really quick?
Yes.
What are we doing?
3 in front of NaCl. 3 in front of NaOH.
Yay.
Are you happy?
Yes.
Let's see. 3 sodium, 1 iron, 3 OHs, 3 OHs. Beautiful. Alright. Any questions?
Nope.
Alright, one more to go. Okay, race?
Yes.
If you want this.
Last one is combustion.
Someone gets set on fire.
So in a combustion reaction,
I volunteer.
the bare bones of it is you take what's called a hydrocarbon,
Oh, that was
basically something with carbon, hydrogen, sometimes oxygen in it. You react it in oxygen gas. That goes to make carbon dioxide and H2O. This would be called a complete combustion, right? Oftentimes in the combustions we do, like when I light a match, for example, we get what's called an incomplete combustion. So when you do this, right? So from this reaction, one thing that we've harnessed for a couple million years now is fire.
Fire. Fire bad.
Fire, right? We now have fire.
Fire bad.
Like stored in
Fire
these
bad.
things, right?
Kill the fire.
Fire bad.
Basically just energy. Energy is released in the sun, right? So that is a complete combustion. This is an incomplete combustion, right? In an incomplete combustion, often what you make is CO2, some carbon, you might carbon monoxide, some water as well.
Water.
Right? This stuff right here, super dangerous, right? This stuff is like skull and crossbones deadly, right? This stuff kills you.
Why?
You guys probably have, a lot of your houses probably have carbon monoxide detectors because you can't smell it.
Can't smell it, can't taste it.
So, like, where do you get carbon monoxide from?
So where you get this from is, one of the easiest ways is to turn a car on. And the exhaust that comes out of the car is often incomplete. And so one of the biggest things that comes out is carbon monoxide.
So, if you get a lot of matches, you'll die.
It doesn't be a lot.
You have to
You
be a lot.
know why people say like you should never turn your car on in the garage with your door closed and running? It's because you produce a lot of carbon monoxide and there's no
Oh, it gets
ventilation.
trapped in there.
And so that's one of the reasons why it's
And we were saying that you have these sensors in your house. Actually, just a few years ago, I think it was like 5 or 6 years ago now, a whole family in Aspen died. They're here on a ski vacation. In the house they were staying in, the furnace in the house, the heater, it wasn't burning the gas properly. And so one of the offset to the products that was coming out was carbon monoxide. Filled the entire house with carbon monoxide when they were sleeping, and they all just died in their sleep. Yeah. Really gnarly. Yeah.
That's why you
So, super deadly. So those are the two types. If you think about sometimes when you're driving in your car, you will see water dripping out of the tailpipe of a car. You see that sometimes? And as we know, carbon dioxide is one of the biggest greenhouse gases out there, and that comes from the cars and a lot of it. Hydrocarbon, this could be anything from that sugar we did, that H12 or C12, H22, O12. It could be
Methane.
CH4, yeah, methane. It could be octane, so it could be, what is that, CAH8? Something like that? Right, that's octane, that's gasoline. Right? Diesel fuel, candle wax, any hydrocarbon, right? So whenever you see something like this, with this, and oftentimes there's clues in like a problem or where it's like, oh yeah, that's like combustion. That's going to be a combustion reaction. One of the things that gets released from this is a lot of energy, right? A lot of thermal energy gets released, as you saw with the match. Heat, exactly. Okay. Questions? So we're going to be playing with some of these reactions today after our break. The chemical reaction party video.
It's gonna be break time, and then we do the upload during break. So enjoy.
So some of the things in this video we talked about, some of the things that we haven't, but you've maybe seen before.